we're talking about inequalities, and there are only two sections of inequalities, and then we're going to go back and start looking at some word problems also. So just as kind of a quick review on some of the things we've done, suppose I want to solve suppose I want to solve this statement. Now notice, you got to notice this is an inequality. It's not an equation, it's not an expression, although it's made up of expressions, but it's an inequality. And so when you solve this inequality, what's the first thing you're going to do here? Distribute what?
The negative side.
The negative 1. So I distribute the negative 1. I get 2x minus 3 is less than or equal to, and what does that become?
Negative x.
Plus 3. So nothing new. It's been on. You've been dealing with this since the first week of school when you dealt with equations and expressions. What's the next step?
Combine like terms.
And I can combine like terms on which side?
The right side.
The right side. So negative 1 and a positive 3 is a positive 2. So I get negative x plus 2. What's the next step?
Combine like terms.
Say it again. What's the next step?
Get the variable.
Get the variables get the variables on one side, constant on the other. So let's bring the variables to the left. So what would I do to both sides?
Add x to both sides.
Add x to both sides. What's 2x plus x? So I get 3x minus 3 is less than or equal to, and that's 0. And then what's on this side? 2. 0 plus 2 is 2.
Add 3 to both sides.
Add 3 to both sides. Combine like terms. I get 3x is less than or equal to 5.
Divide by 3.
Divide both sides by 3. And x is less than or equal to 5/3. Okay. So any number that's less than or equal to 5/3 is a solution to the original inequality. So how many are there?
Infinite.
An infinite number. So that's why we graph them instead. You can't list them. So you have to graph it. So in the number line, notice that this is not an integer, that's a rational number. So if this is 1, this is 2, this is 3, and so on, where would you put 5/3? It's,
Right below the 1.
so between what two numbers?
0 and 1.
0 and 1. Okay. So let's see what 5/3 is. So if I write it as a mixed number, I'm going to say 3 into 5 is 1. 1 times 3 is 3 with remainder of what? 2. So 5/3 is what mixed number? So do you want to change what you said? Yes, you want to change what you said. So 5/3 is between what two numbers?
1 and 2.
1 and 2, closer to which one?
2.
2. Okay. So now remember we talked about open and closed circles. Is this going to be an open or closed circle? Closed because there's an equal sign. See this equal sign, so that means 5/3 is a solution. So right near 2, let's say here, this is going to be my 5/3. And my solutions are located where? To the left of that. So any number that's less than or equal to 5/3. Okay, so there's your graph. Then we talked about interval notation. So when you do interval notation, you got to read it from left to right. So remember this right here, this is inequality notation, because why is this an inequality notation? What do you see? An inequality symbol. Very simple to understand that part. So an interval is where you have those parentheses and brackets. So notice though when you go from left to right, this arrow is pointing towards what idea? All right, and when you use infinity, negative infinity, you always must use, okay. So negative infinity, comma, all the way to what number? 5/3 with a bracket or parentheses. Y bracket, closed circle. All right, so some of you have been either studying this or you remember this. All right. Now let's talk about set notation. All right, set notation. So in my math lab, you're going to have to put something in set notation when you actually do this assignment. And on the worksheet, there are a couple of worksheets on set notation. So here's what set notation looks like. It's very simple. All right, once you have it in inequality notation, this is inequality notation. When you get x by itself with the inequality symbol, that's inequality notation. And so a set, you always use a brace. So a set looks like this. That's a set. That represents a set. Those braces. Not a bracket, it's not parentheses, it's a brace. So you need to make sure you indicate it as a brace. So if you put brackets and I take points off and you come to me and you say, well, you meant that to be a brace? That's not what I see. Okay, brackets would indicate an interval. I'm not telling you to write an interval. We already know what the interval is. I want you to write it as a set notation. So here's how you write it. Now listen to the words. So set notation, you would say this is the set. Remember, this right here means set. The set of, and my variable is x. So the set of x's, so x goes first, such that. So you'll see, if you look through your book, you'll see the symbol right here, like a part of an absolute value symbol. That symbol right here means such that. So the set of x's such that, and then your x's are what? Less than or equal to 5/3. All you do is rewrite this inequality right here, such that x is less than or equal to 5/3. So you're done. That's set notation. We also talked about this last class period. Negative 8x is greater than, let's say, 16. How do you get x by itself? Okay, yeah, you can divide by what?
-8.
Divide both sides by -8. Now, what property am I using here, though? Not equality, inequality. All right, inequality. That's negative 8x is greater than 16. Say it again.
When you're dividing by a negative, you put the symbol.
That's very good. So whenever you multiply or divide an inequality, both sides of an inequality by a negative number, you reverse the inequality symbol. That was the last idea we talked about. So in this case, I'm dividing both sides by -8. It is an inequality, so I'm going to circle this inequality symbol to remind myself to reverse it. So -8 divided by -8 is 1. So therefore, all of my solutions have to be what? Less than -2. 16 divided by -8 is a -2. All right, so the whole point of that particular one is to remind you that when you multiply, divide by a negative number, an inequality, by a negative number, you have to reverse the inequality symbol.
I will never forget that.
All right, and then you do the rest of this like you did before, so you graph it. Now this right here is what notation? Inequality notation. And so the graph, so here's 0, here's -1, -2. So on -2, what do I write? Open circle, because there's no equal sign. So that means that -2 is not a solution. Make sure you understand why. What's -8 times a -2 if you go back and you check it? Positive 16. Is 16 greater than 16? No. 16 is not bigger than 16. 16 equals 16. So it's an open circle. And I want to shade in every number that is less than -2. So go to the left. All right, what will be the interval notation?
Parentheses, negative infinity,
All the way to
-2,
-2 with
parentheses.
parentheses. That's interval notation right here. Once you get x by itself, then set notation that's easy to write. So you're going to say the set of x such that
X is less than negative.
x is less than negative 2, and then you close it. So that's your set notation.
So, because both of these were negative numbers, well, the infinity was negative and the 2 is negative, we didn't use I see we didn't use a bracket there. Had it been a positive number to the right of the infinity, we would have used a bracket.
No, that's nothing to do with whether it be in positive or negative. It has to do whether you see a equal sign or not an equal sign.
Okay.
Okay, and we just talked about the fact that infinity to negative infinity, you always use parentheses. Okay? And if this was greater than or equal to, that would still be parentheses right here. Infinity, negative infinity always uses what? Parentheses. If that was an equal sign, then that would be a what? Bracket. It has nothing to do with whether any of the numbers are positive, any of the numbers are negative. It has nothing to do with that. It has to do with whether you see an equal sign or whether you don't see an equal sign. Okay? All right. Now, if you want to graph, now when we get into the appendix, there's appendix 2 that we're going to look at, and appendix 2 is where we start looking at compound inequalities. In the compound inequalities, the interval is going to look like this. So here's interval notation. Let's say we had this. So these set of numbers are solutions to some inequality, okay? Whatever it may be. But what they want you to do here on one of the worksheets in my math lab and at some point in the appendix, you want to graph this. Well, it's very similar to what we just did a while ago. All of your solutions are between what two numbers here? Negative 3 and 4. Negative 3 is a bracket indicating that negative 3 is a solution. So on the number line, you're going to indicate that with a closed circle. Now your book uses circles. Other books will use brackets or parentheses. Okay? So I just want you to be aware that, now remember, first of all, this is a closed circle, right? And this would be a what? Open circle. Meaning that 4 is not a solution. And so when you graph it, here's negative 3, here's 4. I'm going to have a closed circle here. I'm going to have an open circle here, and all your solutions are between what? Negative 3 and 4. Notice no arrows. There are no arrows here. It goes from negative 3 and it stops at 4. It's still an infinite number of solutions, though. You can't list them. That's an infinite number of solutions. It's not finite. Interval notation, what would that look like? Oh, we already have it. I'm sorry. That's interval notation. Inequality notation. Now, that's going to be a little bit trickier for some of you. Okay, so remember, inequality notation is where you have the inequality symbol. Now, notice that whenever you have an arrow, meaning it's going towards infinity or negative infinity, that's an easy one to write. When it's an interval where it's bounded by two real numbers, you got to be a little bit careful. So basically, negative 3 is the smallest, correct? 4 is the what? Largest, although we can't use it because it's an open circle, but we have the idea. So you're going to say negative 3 is less than or equal to any number that's a solution. So notice less than or equal to x, not infinity, because I've got to go all the way up to just what? 4. And all these x's in here have to be less than what? Than 4. So that's your inequality notation. So notice all the x's are between what two numbers? Negative 3 and 4. There's an equal sign in negative 3 because of the closed circle. So make sure you remember that. There's no equal sign here, strictly less than, because you see a open circle. Okay? Now in terms of set notation, you're going to say the set of x's such that, and all you do is just rewrite the inequality notation. So the set of x's such that what? Just rewrite this part. Negative 3 is less than or equal to x is less than 4. Right. And then one more with that, and then we'll move on. So let's suppose you want to graph 1/2 all the way to, let's say, 7 with the bracket. All right, so on your graph, if this is 0, this is 1, and this is 7, and let's say this is 2, 3. It's not scaled right. I don't have enough room, but it should be scaled. Where would you put 1/2? Between 0 and 1, open or closed? Open. So actually it's right in the middle, right? All right, and then on 7, what will I put? Closed circle. And what will I then do? Shading everything between them. Okay, if you don't shade them, that indicates to me that you're only indicating that 7 is the only solution. 1/2 is not, because it's an open circle to begin with. But there's an infinite number of solutions. Any number in here is a solution. There's an infinite number. Okay, inequality notation. You can say your x's have to be what? All these x's have to be greater than 1/2. So you're going to say 1/2 is less than or equal to x, and x's have to be less than, I'm sorry, not less than or equal to, it's what? Less than. Less than. And it has to be less than or equal to what? 7. Notice there's no equal sign here because it was an open circle. So 1/2 is the smallest. So 1/2 has to be less than all of these x's right here. And all of these x's have to be less than or equal to what? 7. All right. Okay, now let's look at this. Okay, suppose we had 3/4 is greater than, let's say 9. Let's say 9. 3/4 is greater. 3/4 x. Sorry. 3/4 x is greater than 9. That's an x. 3/4 x. All right. How do you get x by itself? Divide both sides by 3/4, right? And then 3/4 divided by 3/4 is 1. 1 times x is x. Do I need to reverse the equality symbol? Nope. Because the only time you do is when you multiply divide by a negative number. It's greater than, so then I got to figure out this part. So remember, dividing fractions, you got to say 9/1 times the reciprocal of the denominator, 4/3. So reduce. 3 times 4 is 12. So all of my solutions are bigger than what? 12. So your graph, if this is 0 and this is 12, what will you have on 12? Okay. Going which way? To the right. Make sure you draw an arrow. You shade it and draw an arrow. Your interval notation go from left to right. So where do I start? At 12. Open or closed? I'm sorry. Parentheses or brackets? Thank you. Parentheses or brackets? Parentheses, because there's no, it's open, right? Corner? Corner. All the way to what? With a parentheses. Negative infinity is always parentheses. Set notation. Brace. Set of x's. Such that. And just rewrite this over. All right. Yep. All right. Number the next one. Suppose we had this. So -6/5 x. Let's make it y this time. Y. -6/5 y is less than or equal to a negative 18.
So the first thing we did, make it to a mixed number?
No, I would leave it as a fraction. No, I would leave it like that, because you would have to divide by a mixed number. So then you have this divided by a mixed number. You would have to change it to an improper fraction in the end anyway. So leave it like that.
Divide.
Divide both sides by.
Negative 6.
Okay, so we'll go ahead and just rewrite it over. All right, so I'm going to divide both sides by negative 6/5. Notice that this is an inequality that I'm dividing by a negative number. So I'm going to have to do what with this? Reverse it. So negative 6/5 divided by negative 6/5 is 1. 1 times y is y. But all my solutions are going to be greater than or equal to. And then let's kind of figure this part out. First of all, a negative divided by negative is a positive. So that's going to be 18 over 1 times what? 5 over 6. 6 and 6 is 1. 6 and 18 is 3. So all of my solutions are bigger than or equal to 15. Okay. All right. Your graph. So this is 15. Is 15 a solution? Yes. So close circle. And I want all this, all the numbers. My solution to be all the real numbers that are bigger than what? 15, including 15. What would the interval notation be? Go from left to right now. You always go from smallest to largest. What's my smallest solution? 15. Bracket. All the way to infinity with a parentheses. Set notation. The set of y's. Make sure you carry the variable. So that's a y. So don't get so used to that x. It could be the variable y. Set of y's such that y is greater than or equal to 15. Okay. All right. Then let's look at this one. All right, suppose we had 4 times x minus 3 minus 1 is less than 2 times 3x minus 1 plus 2x. All right, so 4 times x minus 3 minus 1 is less than 2 times 3x minus 1, and then plus 2x. So what are you going to do? Distribute. You do it just like you would in an equation. It's less than. Oh, do you hear distribute the 2? Okay, good. So 6x minus 2 plus 2x. What's the next step? On the left side, I can combine the constants, so that would be 4x minus 13. A negative 12 and a negative 1 is a negative 13. So less than. Over here, I can combine the terms of the variable x. So 6x plus 2x is 8x minus 2. All right, then let's bring the variables on one side, constant on the other. It does not matter. But remember, this is an inequality, so you gotta be a little bit careful how you write it and how you graph it. So you want to bring the variables to the left or the right? You want to bring it to the right? Okay, we will do both ways. If you bring it to the right, you're going to do this. You're going to subtract 4x, right? And then when you combine like terms, 4x minus 4x is 0. 0 minus 13 is a negative 13. It's less than 4x minus 2. Then what's the next step? Add 2. Negative 11 is less than 4x. Next step. No. You're trying to get x by itself. By 4. Do I reverse anything?
No.
No. So this says that negative 11/4 is less than x, right? Okay, so in your number line, now the numbers already be there. It's not going to be a blank number line. So what might you want to do with this negative 11/4? Change the mixed number to give you an idea where it's located. So negative 11/4. So what's that? 2, remainder of 3. So this right here is negative 2 and 3/4. Is that right? All right. So this is 0. This is negative 1, negative 2, negative 3, negative 4. Between what two numbers is negative 2 and 3/4 located? Negative 2 and negative 3. Close to which one? Negative 3. Open or close circle? Open. So this right here, we're going to say, this right here, let's say it's negative 11/4. And now be careful. Which way am I going to shade in? To the left or the right? To the right. Anybody think to the left because of that less than? To the left? Why are you second guessing yourself?
I ask some questions like that.
We talked about the fact that if the variable's on the right, you have to be careful. So this says that negative 11/4 is the smallest, right? That's the smallest. So remember, we also talked about rewriting this. So you can rewrite this as x is what? Greater than negative 11/4. They mean the same thing. And so you're actually going to the right. So negative 11/4 is the smallest of all your solutions. Although it's not a solution because there's no equal sign. So it's very easy to mess this up if you leave the variable on the left. On the right, excuse me. What would the interval notation? Comma, infinity with parentheses. What will be set notation? The set of the braces, set of x, such that, now it doesn't matter which one you write. You can write this one or this one, does not matter.
So x negative 11/4
Is less than x, or you can say x is greater than negative 11/4. Okay? All right, so that should take care of this worksheet 9.7 part C. So you should be able to start finishing this up. 9.7 part C. Yes, you can do all of them now. So it's do a week from today. Okay, a week from today. All right. Okay, now let's see. One other thing. Let's suppose that we had this. Oh, I forgot to do this. I'm sorry. I said a while ago I was going to do it the other way. So let me go back here. See, in here we brought the variables on which side? We brought them to the right.
Oh, wait.
Okay. So let's go back to this step here, right here. And instead of bringing the variables to the right, let's bring them to the left. So what would I do to both sides? Start with 8x first. What are you going to do? Subtract 8x. Adding 8x is not going to help you. What's 4x minus 8x?
negative 4
Minus 3 is less than negative 2. What's the next step?
adding 3 to both sides.
Add 3 to both sides. Oh, that's supposed to be 13 in it. I'm sorry, 13 right here.
Add 13 to both sides.
Yeah, add 13 to both sides. Combine like terms. Negative 4x is less than 11. What's the next step? Divide both sides by negative 4. I'm dividing by a negative number. So all of your solutions are greater than negative 11/4, which we said right here. Okay? So your graph would be the same as before. So it'll be everything to the right. Your interval notation will be parentheses negative 11 fourths, comma, all the way to infinity. Set notation. So I'm just rewriting this part right here because that hasn't changed. And so set notation, set of x's such that x is greater than negative 11 fourths. All right, so that's what you would have if you had brought the variables to the left instead of to the right. For some students, though, it's easier to bring the variables to the left. They don't get confused with this inequality symbol. All right, and then okay, suppose you had that. Just a very simple one, just to remind you about something. Subtract 5. Combine like terms. So I get negative x is greater than or equal to 2.
And then divide by -1.
Divide by -1. Some of you have a habit of wanting to divide by negative x. You know, I keep taking points away because you can't do that. You got to divide by the coefficient. What's the coefficient of x? -1. I'm divided by -1, so I got to reverse this. So what's negative x divided by -1? It's just x. So it's just 1x, which is just x. Is what?
Less than or equal to.
-2. So all your solutions are less than or equal to -2. So any number less than -2 would work. For example, give me a number that's in here. -3. Okay, so this says right here, this says the opposite of a -3. What's the opposite of a -3?
Plus 3.
What's 3 plus 5?
8.
Is 8 bigger than or equal to 7?
Yes.
Yes. Give me a number that's not in here. 4. So this says the opposite of 4, which is a -4. -4 plus 5 is
-1.
+1.
1.
Is 1 bigger than or equal to 7?
No.
All right, so you can kind of check yourself and see if it seems reasonable. On the graph, if this is 0 and this is -2, open a closed circle because of the equal sign going which way? To the left. So I want all the numbers that are less than or equal to -2. Don't forget to draw your arrow. Interval notation, you go from small to large. Negative infinity with parentheses with a bracket. Set notation, brace, x, such that is less than or equal to -2. Okay.
I have a question.
Yes.
What is the such that explaining? Is it just explaining what x is?
Yeah, it's just that the set of x's such that your solutions are less than or equal to -2. Yeah. So rather than saying the word such that, at least use that symbol to represent such that.
Okay.
All right.
I was just like, I don't get it. It seems repetitive to me, but I guess it is.
So what?
Like you're saying, okay, so x such that is your equation that you started out with. But
Yeah, but you got to rise in the set though. So a set notation, you have the braces. You got to explain what x is, what the solution of x is.
okay,
So that's why you got to have that x in front.
yeah,
You're explaining what your x's are.
okay.
So your x's are any number
But it's,
that are less than -2. So the set of x's, because there are situations in college algebra where your set notation would be this. So you would have two variables, such that a set of coordinates x, y, such that, so that would be set notation there. Okay, so that would be college algebra. So that would be in set notation. So here you just have one variable.
right.
Here you have two variables. So you got to explain what this type of solutions are based on those two variables. All right, now one more, and it's this. So let's suppose we had, this is going to be number 30 on page 700. You have negative 0.3x is greater than negative 2.4. All right, so what are you going to do?
So you're gonna divide
Divide both sides
by
by
-0.3.
negative 0.3. Use your calculator. That's the whole purpose of me putting this decimal there. Negative 0.3 divided by itself is 1. 1 times x is x, but I did divide by a negative number, so I got to reverse this. So all my solutions are less than, on the calculator, what's negative, first of all, negative divided by negative is a positive. What's 2.4 divided by 0.3?
Negative 8 or positive?
Positive 8. Positive 8. So your graph, here's 8. Open or closed?
Okay.
Going which way? To the left. Solution, your interval notation? Uh-huh. With a parentheses, right? Set notation? So the set of, and then your variable is x, correct? And your x's have this form. It must be any number that is less than 8. So the set of x's such that x is less than 8. Okay. All right, so that should, all right, now this is 9.7D, so let me show you what 9.7D looks like. So based on what we did, this is 9.7D. So there are 3 problems, 3 inequalities. The direction says show all workers presented in class. When asked, graph the solution set and write the solution set in interval notation and set notation. So when you get it though, make sure you put a blank here, right here. Oops, sorry, right here. I forgot to put a blank. All right, so interval notation, set notation. Okay, I didn't ask for inequality notation because you get it here, right? Solving for x gives you the inequality notation. All right. Okay, so that's part D. So do a week from today. So there are 2 things so far do a week from today. 9.7 part D and 9.7
Part C?
part C, right? Yeah, I gave you that last class period. Okay, let's go ahead and take one, pass the rest back. Okay, now, let's look at this.